Okay, I hope you've got the right answer. D is $100, okay, $100 a month. You are given that the rate is 0.08, that's 8% monthly, but it does not mean 8% every month, right? It's an annual percentage rate. So it's 8% for the year, but they will divide this by 12 because that's the monthly rate. Okay, K is 12. Okay, and I guess K is most likely, in fact, almost always 12 because your saving is typically done monthly. And then N is the number of years, that's 35. In fact, 35 times 12, did you get that 35 times 12 is 420? Yeah, because you have 420 monthly payments you are making. We didn't calculate this, and this is not such a nice number. In fact, I'm going to move this over here because it's a long fraction, right? How much are you going to write? Well, it turns out to be 0.006666 continuing, right? So you may want to write down like 5, 6 digits of, 5 or 6 sixes. In fact, there is a way to do this without writing down or manually entering a bunch of sixes. Okay, maybe I'll show you that in a moment. All right, let me write this in different color to make this clear. P of 35, according to this, is $100 times that big fraction I was talking about, right? So it's 1 plus 0.08 divided by 12. You raise it to the power of 35 times 12, which we know now as 420. Subtract 1 from it, and then you divide this whole thing by the fraction 0.08 over 12. This is called a complex fraction because you have fractions within one fraction. It's important for you to calculate this part first. Multiplying by 100 is easy. You can always do that at the end, right? So this is the formula that you are going to apply, all right? And I will show you maybe on your calculator, on my calculator again, how to do this. But it turns out to be $229,388.25. So we are talking about, more than 1/5 of $1 million, almost $250,000. And that seems, or that may seem to you as a huge amount of money. But remember, this is your retirement. You're going to have to live for the rest of your life after your retirement on this. If that's all you have, maybe you have a problem. I don't know. Typically a house in the Santa Clarita Valley in California is probably worth a whole lot more than this amount. This amount will not buy you a house. Hopefully by that time you are living in one, so you wouldn't have to buy a house. Okay, but anyway, this is how you can calculate this. Yeah, let's pause this and then I will show you how to do this calculation on a scientific calculator, including this last part here, 0.08 divided by 12. Okay, this may be a little more complicated, but bear with me. Okay, so here again is a scientific calculator, and I will show you how you may want to do this, all right? So you have, first you have that 0.08 divided by 12, all right? That's the ugly number we're talking about, all right? That's, whoa, okay. And then, of course, you have to add 1 to it. And that's 1.006666, right? And then you raise it to the power of, remember this thing here? That power of, so you raise it to the power of what? Okay, and now the thing is, the answer is 420. But if you don't have that number, see these parentheses here? Okay, these always come with your scientific calculator. You can do that, all right? So the power that I'm going to raise this to is parentheses, what was it? 35 years times 12. And I close the parentheses here, okay? So that, if we can see this, that's going to be 420. Now, if I put the equal sign or the enter sign, you will see 1.00666666 all the way raised to the power of 420. Ready for this? If I click on this, this is what you get, right? Now, according to my calculation or formula, I subtract 1 from it, which will change the number slightly. And then I'm now ready to divide this number by, divided by, okay, what? Well, that's a number of 0.08 divided by 12. I can put that in the parentheses. Parentheses, 0.08 divided by 12. close parentheses. Okay, now you see what's happening. I have that expression for the top, and now I'm dividing that by 0.00666666. See, this way you avoid writing a bunch of sixes or entering a bunch of sixes, if this helps. Okay, I'm ready to enter, and this will be the big fraction. This is the big fraction. I multiply this by $100 every month, and the answer turns out to be this: $226,000. I'm sorry, $226,388.24. But this 8 can be used to round this up, so 0.25. The last two digits will be 25 cents, and that's how you can calculate this on your calculator. Okay, so that was your answer. Okay, great, right? Now here's the second question. What if you just put $100 a month under your mattress? This is sort of a metaphorical, maybe I mean literal, but metaphorical way of saying, just keep the cash. Okay, don't trust banks and just don't trust any kind of investment. Cash is the best way to save money. Let's keep $100 every month under your mattress for 35 years, hoping that nobody's going to take it away and no wildfire is going to come and burn your house down. Okay, so if that happened, by the way, nobody in your family finds out and start taking away the amount of money. All right, so if you do that, this is what you expect: $100, 12 times a year for 35 years. And you already know this is 420. So this will be 420 times 100, 42000. And so that is $42,000 after 35 years. Notice the difference? This is what I mean by the power, okay, of compound interest. Compound interest is great if you save money, power of compound interest, because after 35 years, after a long period of time, okay, compound interest is powerful, okay? Instead of 42,000, you'll end up with more than, about 5 times as much. That's $229,000 plus. Okay, the difference between these two amounts, one is how much you'll have after compound interest. The other is how much you put into it. Okay, so the difference between these is actually 187,388.25. This is the total interest you earned, or not you, but the money has earned for you. Okay, that's the power of compound interest I was talking about. Okay, so notice here, I will be asking you how to, to calculate the total interest. And so know that that is obtained by finding the difference between the total amount you will have at the end and the total amount that you invested. Okay, the last example here before I do a little comparison here is this college fund example. Suppose that you want to invest money for your child's college education. That's a noble thing, and the child was just born. Okay, so you have about 18 years to save up. Assuming that the child is not going to college until he or she is 18 years old, you want to save up so that the child will have $30,000 in 18 years. That's also very noble. Okay, no comments. All right. Private or public school, that's a difference. 4-year college or community college, that makes a difference. If you can invest your money at 6% monthly, which is reasonable, maybe it's hard in these days, but it's possible to for your money to earn 6% every month. 6% monthly, that's 0.5% every month. How much do you have to set aside every month for 18 years? Okay, now we have not asked this question before. We have not answered this question before, because this time we are trying to find what D is. Okay, how much do you have to set aside every month? Okay, can you do this problem? I hope you can, and this is how. Let's write down all the information we have so far. We want P sub 18 to be 30,000, right? That's the first thing you are given. You're also given that R is 0.06. K, of course, is 12 because it's monthly, and N is 18 years. Okay, so with this, and D is what we don't know. Okay, and I think with this, you can figure out how to answer this question here, right? So D is what we don't know, right? just write D. I know it looks like an algebra formula. Well, it is because we're trying to look for the unknown. But that's okay. Don't, let the word algebra scare you away. Because you know so much more now. You know the formula, right? So what is that formula? Well, you have 1 plus, and remember you have to do R over K, right? So that's 0.06 divided by 12. This is an easy one at this point. Let's go ahead and write down that number instead of writing, 0.06 divided by 12, which you can if you like. You raise it to the power of 18 times 12. By the way, you can also calculate this ahead of time. That's 18 times, 18 times 12. And so that's a number of months in the 18-year-old year period. Okay. And so you can calculate this ahead of time if you like. And that's 216. That may help you, to simplify your calculation. And then you subtract 1 from it. Why? Because it's part of a formula that comes from the geometric series. And then you divide this by 0.005, right? Which is, by the way, this thing here. You could write 0.06 divided by 12 in the denominator, but this makes it a little simpler, I believe. Okay. And then you just calculate this part. All right. You want to calculate this again together? Yeah, let's do that. All right, so the college fund example, I have 0.06 divided by 12, and that's of course half of percentage. You add 1 to it, okay? So you have seen this before. Now you raise it to the power of, not multiplication, but this one here, okay? X to the Y, or sometimes the caret notation. This raised to the power of, we had 18 times 12, but we already calculated that to be 216 monthly payments. All right, so you can set that equal to this, subtract 1 from it, minus 1 equals, okay? And then you divide this by, remember, 0.005, right? Okay, and that's going to give you this amount, and times D is equal to, so let's go ahead and write this number down because we need to have that number. See, the unknown this time is D, so we have to figure out what D is. See this number? Try to write down many digits of this number, and then we will do the final calculation. Okay, now our P18, that's 30,000. Okay, we want 30,000 to be D times this whole thing, which was 387.3531944, whatever. Okay, now how do you find D? You see that? Okay, again, this is a very algebraic step, but it shouldn't scare you because all you have to do is, if this times D is 30,000, D is 30,000 divided by this number. You see, you're dividing both sides of the equation by 387.35319, blah, 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 okay? And so the answer to this is, and you can round this off to the nearest penny, $77.45. If you do this properly, this is what you get. Now, let me go back to the calculator and show you how to do this without actually having to write down this number. Okay, so this is not what I had before. Okay, so remember this is your big fraction. The value of the big fraction is this. This times D is what we want to be $30,000. So the answer D was 30,000 divided by this, right? Okay, so what you can do is you can divide this by, or divide 30,000 by this number. Now, sometimes you have the answer key in your calculator. Then all you have to do is to do 30,000 divided by the ANS, the answer. Okay, this scientific calculator does not have that amount. So what I will do, and this may be tricky, but I will divide this instead by, watch this, okay, divide this by 30,000. And of course, that's not the answer, okay, because I divided in the wrong way. I was supposed to divide 30,000 by 387, but now I divided 387 by 30,000. And so this is not the answer, but it's exactly the backward. It's called the reciprocal. 1 divided by this, or the opposite of this, is the answer. So there's a quick way of doing this, and this is 1 over x. This will give you the reciprocal. So if you are looking for a divided by b, and but if you did b divided by a, then what you really want is a reciprocal. All I have to do is click on this, and that will give me the answer. So this is the result of 30,000 divided by 387.3531944. And that is your monthly payment, $77.44 or 45 cents. Okay. Oh, that did not work. And so that was, no, this is something else. Okay. So the answer was 77.45. All right, so think about this, okay? And this is not a huge amount of money, right? I don't know, for young parents, it is difficult maybe. But if you, let's say, just, have a child and 18 years from now, you want the child to have $30,000. And if you can set aside amount of money every month for 18 years at 6% monthly, all you have to do is to set aside $77.45. Stop going to Starbucks a few times a week, whatever, and save up this amount instead for the next 18 years. That would require lots of discipline for a long period of time, but you in 18 years will have $30,000 to give to your child as your child starts the college at age 18. And $30,000 would be a good way to start the college. You may be able to afford a couple of textbooks by that time. By the way, private schools will charge you a lot more than that for room and board. This is not even enough to go to the first year of college in many colleges in these years. And who knows what's happening 18 years from now, right? Okay, but let's compare. This is a comparison exercise. Find the amount in 20 years. If you can set aside $100 for 20 years, okay? In all of these cases, let's go ahead and write this down maybe in different colors this time. N is 20. Oh, okay. And monthly. So K is always 12. In this first case, R is 0.06. Oh, by the way, in each case, D is $100. You are setting aside $100 every month for 20 years in all of these cases. Okay. The first one, it's 6%. Second one, oops, that's not R. Is 7%. What's the difference in 1%, right? I mean, after all, 7%, 6%, it's only 1%, who cares, right? Well, you may want to, okay? What happens if it's 3%? Okay, so that's the difference. All the different answers will come up. Obviously, this is the best bet, but how much of the difference are we talking about? Are you ready to calculate this? In each case, you're looking for P sub 20. First one, it'll be 100 times, in fact, all of these will have, this same expression at the beginning of the calculation. Okay, P20 is equal to 100 times. This part is all the same. Okay, maybe I'll use different colors now. What are we doing here? Okay, so this will be, remember, 1 plus 0.06 divided by 12. That would be 0.005. Add 1 to it, and raise it to the power of n times k. In all these cases, you will be making 240 deposits. So the power is always going to be 240. Subtract 1 from it and divide it by 0.06 divided by 12. I said you don't have to memorize this formula because virtually nobody in the world has this formula down. Okay, maybe I'm the only one. A few other math teachers. Okay, and that's because people in finance don't do this calculation by hand, right? I mean, you can sort of imagine this, right? I have seen many bankers, many people who sit in, a car dealership, and you ask them how they calculate this, and they say, oh yeah, we use compound interest. They have no idea what formula they are using because all they do is punch in a bunch of numbers into the calculator or computer, and somehow that gives you an answer. In fact, you can do this if you find the right website. This will calculate this for you, okay? So that's the answer for the first question. The second one will have 1 plus 0.07, right, divided by 12. The only difference is really that the rate, 0.07 divided by 12, okay? And then the last one, 1 plus 0.03 divided by 12. raised to the 240th minus 1 divided by 0.03 divided by 12, right? Okay, so, and you can do this calculation, all of these calculations, and then come up with an answer. You know what? I think I will show you how to do this for the most complicated one. See, the fraction, this fraction, 0.06 divided by 12 is a nice number. 0.03 divided by 12 is also a nice number. The middle one is probably the most troublesome. And so let me show you how to do the middle one. Okay, now remember, you can do a 0.07 divided by 12, and that's going to be an ugly number. That's your rate per period. That's 0.58333% per month. That's exactly what that is. Okay, now you add 1 to it, plus 1 equals, and that's inside of the small parentheses. You raise it to the power of what? Here's the power. Okay, and if you don't know what that number is, you can use the parentheses. It's 12 times 20. Remember, it's 240 deposits you're making. And so you do that, you raise that 1.00583333 to the 240th power, and that's equal to this. You subtract 1 from it, and that is the numerator, the top of this. And then you divide it by what? Okay, well, again, I can use the parentheses, and so that's 0.07 divided by 1, 2, okay, 12. That is your the rate per period. And then you set this equal to, that is the big parentheses or big fraction, okay? And all you have to do is to multiply this by 100 and you will get your answer, 52,000 plus. We'll write that number down. Okay, so that answer was $52,092.67. All the other ones are done the same way. This one will give you 46,204.9 cents. And then the last one with 3% will give you 32,820. Okay, so calculation wise, that's done. Okay, if you're a robot or if you're a programmer, then this is done. You're done, go do something else. Okay, if you are a human being, stop and think about it. Okay, and I'm telling you to stop and think about this. 20 years of hard work and you are saving $100 every month. It does make a difference, okay? Pay attention to this. It makes a difference if it's 6% or 7% or 3%. People say if you're young and if you have a full-time job, you know, to invest aggressively in the higher rates of return because that's going to make a difference. All right. The difference between the aggressive 7% and the 6% is after so many years, after 20 years, about $6,000. Sorry, about $6,000. Okay. 3% and 6%. The difference between this and this is about, what is it? About $14,000 or $13,000 or $14,000. Okay, so the percentage is a huge factor in investment. Even the 1% percentage point difference will give you a difference of thousands of dollars over the course of many years. So keep this in mind, and this will help you save you know, sufficient amount of money. Money is not everything. That's not the most important thing in life, but knowing this will help you be financially wise and financially independent, and basically an overall good, you know, reliable and dependable, stable person, financially speaking. And so this is a good lesson for you. Remember, the power of compound interest works for you if you save money, and it'll work against you if you borrow money, as we will see next time. So again, all right, just make sure that you know how these things work. Okay, next time we'll go into the following lesson, the next lesson, where we talk about borrowing money, and you want to be especially attentive as you listen to that, because the power of compound interest, okay, that would work very much against you as you borrow money, especially for a long period of time. All right, until then, I will see, have a great time and a good week. Take care.